Hello everyone, welcome to Cloud Intelligence. Today's topic is Databricks Workflows. We will explore Databricks Workflows with the latest features and discuss how we can utilize them with a use case. Let's understand the meaning of Databricks Workflows. Databricks Workflows orchestrate data processing, machine learning, and analytic pipelines on the Databricks Data Intelligence platform. Workflows has a fully managed orchestration service integrated with the Databricks platform. Let's examine the components it needs to support for orchestrating our data analytics and AI process. First one is jobs. We can say a Databricks job is a way to run our data processing and analytic applications in a Databricks workspace. A job is composed of one or more tasks. In a task, you implement your data processing and analytics workflow. A job task execute your code, which can be found in a Databricks notebooks or Python files. Additionally, there are many other supported types that we will explore during the demo. To execute these jobs, we need some compute power. So Databricks clusters and SQL Warehouse provide the compute resources for our jobs. We can run these jobs with a job cluster or an all-purpose cluster or a SQL Warehouse. Next, we need to execute these jobs. That's a scheduling mechanism. We can run jobs interactively from the jobs UI or jobs API or command line interface. Alternatively, we can schedule jobs to run continue as a continuous job or create a schedule to run jobs periodically. Additionally, jobs can be triggered to run when a new file arrives in a external location such as Amazon S3 bucket, Azure storage or Google Cloud storage. To be able to use this feature, we would require premium workspace with a data Unity catalog is enabled. Once these jobs are running, we need to monitor they have been succeeded or failed, as well as how long they have been running. We can observe this by reviewing the job history. Additionally, we can set up a notification to an email or other communication channels such as a Teams or Slack or webhooks. The next last one is a parallel task execution. Parallel task execution means the task can run simultaneously without waiting for the previous task to finish. If they do not have any dependency, this allows us to run them in a parallel. Let's explore a data flow use case for which we will create a workflow. Imagine we have a requirement to extract data from a REST API and load it into data lakehouse. Initially, the data will be stored in a raw area in the form of a JSON files. With a minimal transformations, we need to load all these JSON files into Delta Lake cleanse tables. By applying some aggregations on these cleanse tables, we need to load this data into Delta Lake curate tables. As you seen here, there are multiple stages. We can say stage 1, 2, 3. To achieve these ones, I have created a few notebooks. First one is the which will extract the data from a REST API and stores the data in the form of a JSON files. And second one is the which loads all these JSON files into Delta Lake cleanse table with applying some minimum transformations as we needed. And third notebook which I created which implements the some aggregations and loads the data from cleanse to curate tables. Additionally, I have created two Python files to demonstrate the parallel execution. By using all these notebooks and Python files, we will create a single job and utilize all available features such as passing values between the task and parallel execution and scheduling, monitoring, and notification in our workflows. Let's proceed to the Databricks workspace. Here we are in the Databricks workspace. As I mentioned previously, I have three notebooks and two Python files which we are going to use them in the job. Let's quickly explore the code inside these Python files and notebooks. In a etl underscore staging.py file has a print statement says data load starting. Let's look at the parallel.py file has also print statements says parallel execution. The main aim of these two Python files to prove the parallel execution in the job. Let's explore the first notebook, which is extracting the data from a REST API and store it into Azure Blob Storage in the form of a JSON file. If you look at the PowerPoint slide, this is equivalent to the task 1, which extracting the data from REST API and storing in a JSON file in a raw area. Now let's look at the second notebook, which is reading all the JSON files into a data frame and applying a minimum transformations means here I am creating an additional column called inserted date time with a current timestamp. And this modified data frame I am writing back to into a delta lake cleanse table in the form of delta. And here I am creating a SQL table in the Hive Metastore. And this is the last main one. I am passing the cleanse table name to the next task by using the task values. Now let's look at the third one. In this third notebook, I am reading the value from the previous task, that is the cleanse table name. By using that cleanse table name, I am reading that cleanse table name data into a data frame and applying the aggregations means here I am creating a new column called price increase based on an existing column, price column, and just adding of a 50% to that existing price column. This modified data frame I am writing back to a delta lake table in the curate area. So finally just I am creating a SQL table in the Hive Metastore. Now let's create the workflow. To create the job, navigate to the workflow section. In this section you will see jobs, job runs, and delta live tables. This delta live tables is only available in the premium workspace. To create the jobs, just click on a create. You will come to this different user interface. In this user interface, if you see it in the type section, you can run the Databricks notebook or you can run the Python script, means you can run any Python file, and Python wheels mean you can run the Python wheels which resides in a DBFS location or remote location. SQL means you can run all the SQL statements against to the SQL data warehouse. Delta live tables pipeline, you can run the delta live tables in this task. dbt means this is a third-party transformation tool. You can run dbt models in the Databricks also. Jar means you can run the jar files. Spark submit, you can submit the Spark jobs to the Databricks. Run a job means you can run another job from this task. If else condition, by using this if else condition you can modularize your workflow. So next one is the compute power, which is a cluster. As you see here, there are three types of cluster as we discussed earlier: job cluster and all-purpose cluster and SQL warehouse. Job cluster is the more optimal and cost effective. You can see dependent libraries. You can add any dependent library to run your code, either Maven or anything you can run onto this cluster. And parameter, you can add the parameters to make a dynamic as flash. Even you can pass the job parameters or task parameters, and Notification, you can add the notification even task level, not only job level. You can add a notification on the task level as well as. And retries, you can specify the how many times. If is there any failure, you can try the retimes, how many times you want to do retries. And duration threshold, which is the you can mention here. For example, in a scenario, if your task that will take only 5 minutes, you can give a buffer time, maybe 2 minutes, additional 2 minutes, which is a 7 minutes. If it's running for the 7 minutes, you can raise it warning. If it's you can put the maybe maximum time. If you want to run only 10 minutes, after 10 minutes you want to stop it, you can put the time 10 minutes here. Then Databricks automatically it will terminate your job or task. Okay, now let's give a job name ELT6 and give a task name which is a task 1. Let's go, we will run the Python script which is in our notebook. Source, where is this is a source location. You can run the Python script which resides in your workspace or DBFS location or remote location, which is a Git provider, either GitHub or Azure DevOps Git. And choose the Python file. Where is the Python file? Where is your Python file? So this is our first Python file we want to run. And if you choose which cluster you want to choose, again existing job cluster or new job, you can create a new job cluster. For now I'm using the existing job cluster. And you can pass any parameters for this Python file if you want to pass any parameters. Okay, let's create a task and add another task. When you add another task, it's directly asking what type of task you want to run here. I want to run the another Python file, right? So let's run the task 2. Okay, this is a Python script again. So I'm going to navigate to the Python file, which is a second file here. This is the one. I'm going to use the same cluster. So it says this is a section you can say dependent on, but this is not dependent on previous task. So I'm not gonna select here. Now these two tasks will run in a parallel. So if you want to pass any parameters, you can pass it. No, I don't have any parameters, so let's create a task. Okay, now let's add this is the actual data flow which we doing. So this is a raw one, and we want to run the notebook, which is notebook is inside our workspace, and select the notebook path. So this is the first one. Okay, I'm going to use the same job cluster again. So now in this section it says task dependent on task 2. We can choose multiple also. See if we choose a first and second one. If you see here, these raw one task is a dependent on task and task 2. Okay, let's move on. Even you can choose the condition run if dependencies all succeeded or failed or none failed, all done. There are various conditions. For now we'll choose all succeeded. Create a task. Now let's create another task which is loading JSON files into silver table, right? Which is a cleanse table. So again, that's also notebook also in our node workspace. Now select the second one. This is the one location, and I'm using the same again the job cluster, and this is a dependent on a previous one. We have to keep it. We don't need to keep others dependent, but this cleanse is dependent on raw. So even when it succeeded only we need to run, otherwise we don't want to run this one. Let's create that task. Now let's create another last final task which is curate one. Curate. So this is also notebook, and source is a workspace, and path is here. This is the third one. And same, I'm using the same cluster again, job cluster, which is existing one, and dependent on cleanse. So this is a curate, right? So this is a cleanse. Here also we are passing the table name from here to here, cleanse to curate as well as you previously seen in the notebook. We mentioned that one using the dbutils.jobs.task value. So for now, yeah, as you seen here, now our workflow has been created. You can minimize and maximize, you can play around it. So this is the workflow. So these two are Python files which they need to run fast. They don't have any dependency, so they will run parallel. And the next one is the raw area one. Then the second one is the cleanse. Then third one is the curate. This is the workflow. Okay, if you want to run the job, you can run it from here. Before we running the job, let's explore the other options or other features. So for example, this is a job details. You can see job ID. Here is a job name and creator, the username, run as a username. Initially it says whoever creates the username, that will be run as a username. You can change it to the username, maybe service principal or something you can change as well. As in the tags section you can add the tags. This will help you to understand the cost to run this job, uh, because when you're running this job you will spin off the some clusters that will results to some cost, right? So based on the tags you can segregate the cost, and you can add the description, and the lineage will provide the lineage, and you can enter this job, you can add it to the git as flash. And this is the other one, schedules and triggers. You can schedule this job in as I said, like three types. One is the continuous job, and second one is the scheduled one, third one is a file arrival. So this file arrival only available in the, as I said previously, only for the premium, plus the Unity catalog should be enabled. Schedule means you can schedule when do you want to run, what time you want to run, some like that. Continuous means it will run continuously. File arrival means you need to have a volume to be created in the Unity catalog. Then you can use this option. When the file is arrival, you can trigger the job. Okay. And the next is the compute power. This is where we need to given the job cluster for now. Okay. Job parameter. You can pass the job parameters to run the job as well as there is any job settings. You can have the job settings as well as how many concurrent runs you are allowed to run, or some other settings you can make here. And the job notification, here you will configure the notification for them. If the job succeeds, what will, if you want to add any, if you want to see, if you see, you can send the notification to email, Teams, and Slack, webhook as well as when you want to send it, in the start of the job or success of the job or failure of the job. You can send all the information, all the stages you can log it. So even you can, if you want to allow others to modify the job, you can manage the job access as well as. So now we can run the job. Let's go and run our job. Before running the job, there is a, let me show you this one. This is due to the limitations in my subscription, I won't be able to spin off additional cluster. So there is an option, you can swap all of them to the all-purpose cluster, which is I am using currently now. I can swap it. Let me update all of them. So all the tasks will get updated to the different cluster. And also this swap is very useful when you, for example, in a job is failed, then you want to quickly debug it. Instead of spinning the cluster, you can use the existing any other cluster, all-purpose cluster. During the debug time, it will be very helpful. Now you can click on the run now as well as, if you have any parameters, run now with the different parameters. You can pass different parameters here. For now we don't have any parameters. Let's run the task now. Now if you click on view runs, if you are, otherwise If you want to monitor the progress, you can go to the workflow section and job runs. So at the moment that's jobs are running, all of them. So if you see, look at this is a ELT6 is our currently running job. This is the one we clicked on run now. So you can see it's a running status, and if you see here, it's running here, and you can see the user interface how it's a. And if you click on the run time, this is the one. If you do here, it shows, see, if these two parallelly executed, these two completed, now it's running the raw area, and we'll see that data in the tables as well as. On second, I will show you that data in the tables as well as once completed. For example, curate table will have 0 records for now because it hasn't run now. See, curate is not started. We'll see here. Yeah, that's right. As you see here, curate table doesn't have records. It's still not yet running. Once this is completed, we'll see into green area. If you want to cancel the job during the run, you can see you have an option to cancel here as well as. See, its cleanse is completed now. Let's go and see the cleanse table. This is a cleanse table. It should have some data. Let's do this one. See, we have some data, and the transformations we applied is the inserted date time. This is the inserted date time, which is the today's date. Okay, and let's see. Yeah, see, this is a. Okay, as you seen here, curation task is failed. Let's see why it's failed. So let's debug it. Okay, once you click on that one, it highlights the highlight error. So it's when you click on here, it will highlight the, okay, this is the failure which happened here. So as you see in here, as I said, like we are getting the table names from the previous task. We need to give that actual task name. Let's go and see the task name. What is the previous task name? This is a cleanse. As we know, Databricks is a case sensitive. So we need to pass the lowercase cleanse, then it should fix it. So let's go to the notebook and edit the notebook. Okay, this is the one. We need to change the to the cleanse, which is a lowercase cleanse now. And now we can say repair and rerun. So we don't need to pass anything, and repair and rerun. Okay, now it's look at the rerunning. So now it's rerunning now. Now as you see in here, curate last task also succeeded. So let's go and validate the data. Let's go and see the both table. This is a cleanse table, and the next one is the curate table. This is the one. We should be able to see the same records. Yeah, let's go and see the, yeah, all records here. And also we should be able to, yeah, this is the new column name which we created. So price increase, this is the column which we created in the last notebook. So this is about the workflows. We can manage these workflows using the job interface as we seen here, or you can use a job API and also Databricks CLI as well as. For the continuous integration and continuous deployment, we can leverage Databricks Terraform provider, or we can use the Databricks asset bundles, which we say DBA, which is currently in a preview mode as of April 2024. In a summary, we have explored Databricks workflows and how they enable us to orchestrate data analytics and AI process. By passing values between tasks, we can make jobs more dynamic. Utilizing job clusters allows us to reduce the cost effectively. I will add all these notebooks to the GitHub and include the link in the description below. Thank you for watching. If you have any queries, feel free to ask in the comment section below.